Hello everyone, and welcome to the first video in our factoring polynomials unit. The topic for this video is going to be factoring polynomials. The first thing I want to talk about is factoring versus multiplying. These are opposite operations. So let me give you an example. Example 2x times 3x minus 7. Okay, this is multiplication. We distribute, and I know you guys know how to distribute. We end up getting 6x squared minus 14x. When we go in this direction here, this is multiplication. We start off with factors, and we end with a product. When we're factoring, we simply reverse everything, so we do the opposite. Instead of building up, we break down. So for factoring, we would start off with 6x squared minus 14, and then we would end up factoring this. Now this would be the product, and we're going to end up factoring it into its factors. There's many methods to factor with. We're going to look at different methods in this unit, and I'm not going to explain how I factored this one. Well, actually, I will. It's greatest common factor. We're going to go through it. We're going to learn how to use this method today. But this would be factoring. So now this is factoring. With factoring, we start with the product, and we end with the factors. Now, why am I going over this? Because sometimes students they'll get confused when they're dealing with polynomials. Should they be multiplying? Should they be factoring? And then they'll think they're factoring, but really they're multiplying. So hopefully this makes it a little bit clearer. When we're factoring, we're going to start with the finished product, the product. Then we're going to break it down into its component factors. All right, let's start learning how to use the greatest common factor method. The first thing we do is we want to look for this greatest common factor. So I suggest, at least when you're first learning, to break things up. So let's look at the numbers first. So 12 and 6. What is a number that can be multiplied to make 12 and multiplied to make 6? So there's likely a few you can think of, but we want to pick the greatest one, the largest one if possible. So the largest one that I can think of is 6. So I'm going to write that out. So once you think of the greatest common factor, or part of it, you write it out. Next, we're going to check the variables. So I have an a, 12a. I look for other a's. If there aren't any other a's, then I know that won't be part of the greatest common factor. I see that in the second term, there's a c, but there aren't any other c's in this polynomial, so it can't be a part of the common factor or the greatest common factor as well. So it looks like our greatest common factor is simply a 6. Sometimes there's lots of parts to the greatest common factor, sometimes there isn't, like this one. Once you remove the greatest common factor, what we want to do is we want to rewrite what this polynomial would be once we remove that greatest common factor. So instead of 12a, it would be 2a, because 6 times 2 equals 12, but we pulled the 6 out, so we'd have 2a. And then now we've removed the 6 from the 6c, so I just have a positive c. And then we're done. We've factored this using the greatest common factor. The nice thing about factoring is you can check your answers. So now I can use the opposite operation, the multiplication, and see if I get back to my answer. So that is going to be 12a plus 6c. That's what I began with, so perfect. I'm correct. Let's look at our next one. 3 terms. So it just means I have to check all 3 terms for something common. So if you have something common for 2 out of 3, that's not good enough. You need to be 3 out of 3. So again, let's look at our numbers first. 14, I'm sorry, let's use a different color. 14, 21, 35. Well, when I'm thinking of this, 7 pops up. So I'll write 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 5 is 35. Now I'll look at the letters, and I can see there isn't an x in each term, and there's not a y in every term, so there won't be any variables part of this greatest common factor. So I'm done the greatest common factor. I write it out. I write it out, I make my bracket, and then again, now I'm going to go through and rewrite each of these terms with the 7 removed. So like I said before, what makes 14? Well, 7 times 2 makes 14. So I'm going to put 2 down, and then the x, because the x is still there. I've removed the 7 from negative 21y, so then I would have negative 3y. I've removed the 7 from the positive 35. I'd be left over just with a positive 5. Again, this is my GCF. this is just my adjusted, I'll call it, polynomial. It's what the polynomial is now once we've removed that greatest common factor. All right, you can see we're adding some details to these polynomials. So now I have, again, we're going to look at the coefficients, the numbers, and let's see what's common. Well, in these ones, 3, 2, and 5, they're all prime numbers. There's nothing common there. So for this greatest common factor, there won't be anything. There won't be any number part to it, and that's okay. But if I check out the a's, you can see that there's a's common to all three terms. Now, how many a's common to all three terms? Well, a to the fourth ends up being A12, well, there's going to be 12 of these, so I'm going to be quiet and write these out real quick. I think that's 12. And then for a cubed, there's 3. So what's common is each term has at least 1, 2, 3 a's. So a cubed will end up being my greatest common factor. When I'm dealing with variables, I like to tell students that the most you can take is the least that one of them has. So the most I can take was a to the power of 3 because that's all that a to the power of 3 can give up. It only has 3. It can't give you 4. There's only 3. All right, so same thing. Now we just divide out the a3. So 3, a to the 4th power, what does that equal? Well, it'd be 3a. Once I remove the 3 a's from the second term, now I'd have just a to the 9th. And from the third term, a to the 3rd power divided by a to the 3rd power, that's just 1. There we go. D. Again, check out the coefficients. When you check out the coefficient, make sure that you're considering the signs as well. So I see negative 12 and negative 3. They're both negative. So I'm going to right away, I'm going to pull out the negative. And then when I'm thinking 3 and 12, well, 3 times 4 equals 12, and 3 times 1 equals 3, so 3 works. Now I'm going to consider the y's. Okay, and I have y squared is 2y's, y cubed is 3y's. So there will be 2 y's in common. So I can pull out y squared. Just trying to get back to my black color. All right, now I write the adjusted polynomial. So if you want to think of it through division, or you want to think of it through multiplication, it'll accomplish the same thing. Sorry, I'm kind of have a hiccup here. It'll accomplish the same thing. So it's just kind of how you want to think through things. So let's do the division style right now. Negative 12 divided by negative 3 is positive 4. Y squared divided by y squared, that's 1. In a multiplication, I don't need to write the 1 down because it'd be 4 times 1. 4 times 1 is simply 1. Next term, negative 3 divided by negative 3, well, that's positive 1. And then y cubed divided by y squared will be just y. So I could have written this as negative 3y squared 4 plus y, but if you feel like writing 1y, you can. All right, moving on. Again, things are just getting slightly tougher. Okay, I'm going to consider the coefficients 16 and 40. Well, what jumps out to me is 4 initially, and then when I'm thinking 4, I'm going to think, well, it could 8. And yeah, 8 times 2 equals 16, and 8 times 5 equals 40. So I'm going to pull out an 8. For the x's, again, the most that one can give is the least that one of them has. So I see x squared. So the most, there's going to be 2 common x's in each term. For y's, y to the 4th. Because we know 16 x cubed y to the 4th has 4 y's in it. And 40 x squared y to the 6th has more than 4. Perfect. So that's my GCF. Now I'm going to divide that GCF out and write the adjusted polynomial. So 16 divided by 8 is 2. X cubed divided by x squared is just x. Y to the 4th divided by y to the 4th, well, that's 1. So I could write 2x times 1, but that just equals 2x, so I'm going to choose not to write the 1 down. Positive 40 divided by positive 8 is positive 5. X squared divided by x squared, that's 1. Again, I'm not going to write that down because 5 times 1 is simply 5. Y to the 6th divided by y to the 4th is y squared. And there we go. Before you leave a question, you should always just give a quick look and see, is there any more that I can pull out? And in this case, there isn't, so now I feel good to move on. Okay, F. I see 3 terms. I see each one's negative, so I'm going to say negative. 15, 20, and 30, What jumps to my head is 5 right away, because 5 times 3 is 15, 5 times 4 is 20, 5 times 6 is 30, so negative 5. Now I'll check out the b's. I see that there's a b squared, a b cubed, and a b to the fourth, so b squared would be common. And then the x's, again, the most you can take is the least that one of them has. So that's the x cubed. So there's my GCF. Now simply go through and divide. Negative 15 divided by negative 5 is positive 3. B squared divided by b squared equals 1. I don't need to write that. X to the fourth divided by x to the third. Remember, when you're dividing your powers, you subtract your exponents. So really it's 4 minus 3, which is 1. So x to the first power, or just x, your choice. Positive 20 divided by positive 5 is plus 4. B cubed divided by b squared. So at 3 minus 2 is 1, so b to the first power, or just b. X cubed divided by x cubed, just 1, I won't write it. Negative 30 divided by negative 5 is plus 5. B to the fourth divided by b squared is b squared. Then x cubed divided by x cubed is 1. So there we go. Again, I could check it if I wish through multiplication. And before I say I'm done, I'm going to look at this really quickly, and I see, oh, there's some b's there that look common, but the b's are not common to all three, because you can see the 3x, it does not have a b in it, so the b is not common for this. Moving on. In summary, identify the greatest common factor within the polynomial. Then remove the greatest common factor and adjust the remaining polynomial. And this is how it kind of looks. Remember, we have the greatest common factor here, and then the adjusted polynomial. I hope this video helps. If it doesn't, find one of your teachers or contact me. Have a great night, everyone.